Jai Hind to all. Myself, Dr. Yogendra Prajapati, Assistant Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to teach a very important topic of the theory of automata and formal language, that is known as the minimization of the DFA. Before going to teach this topic, first we discuss formal definition of the DFA and what is the application of the DFA, then move on the minimization of the DFA. This topic is very important in the term of the university examination. In GATE examination, this topic frequently not asked. So, but with respect to the university examination, definitely every year this topic asks the question. Now, first we discuss the formal definition of the DFA. Now, DFA consists of the 5 tuples. Now, Q, sigma, delta, Q naught and F. Now, what is the Q? Q is a set of state. Finite automata, yeah, deterministic finite automata consists of the n number of the state. Now, sigma is a set of inputs. Set of inputs either A comma B or it is 0 comma 1. Most of the book refer only to inputs for the computational problem. Now, delta is a transition function. Now, here is a 2 to power only q, not only q. Set of state and sigma and final find out the state, that is the transition function. Now, initial state, it is a subset of the q. It is set of the start state or it is known as the initial state. Now, F is also a subset of the q. Now, it is known as the accept state or it is known as the final state. Now, here is a q. Q is a set of subset of now this one. Now, this one is the very famous example for the minimization of the DFA. Now this is the DFA and we make the transition table. Now, we check the transition table. Now, Q0A, we find the Q1, it is right. Now, Q0B, we move on the Q2. Now, Q1A, Q2, Q1B, Q3. Q2, now Q2 this one, from Q2A, Q4, now this is the Q4, Q2B, now Q2B, that is known as a Q6. Now, with the help of this DFA, we make the transition table. Now, when we are going to minimize, we follow the 3 steps. The basic concept of the minimization, similar type of the state are lie into a same group. What is the similar type of the? Similar type with respect of the transition function. Any which state have a similar transition, then that state are lie into a same group. Now, we check Q5 and Q6. Q5 and Q6 have a similar behavior. From A, it is both are the Q5 and for the B transition, it is Q6. Now, Q5 and Q6 have a similar behavior, so that it is lie into a same group. Now, there are the some steps. What is the some steps? We minimize the finite automata. First, these all state are classified into a two part. The first part is known as the set of final state and set of all non-final state. Now set of non-final state. Now what is the non-final? This one, this one, this one, this one, this one. It means Q0, Q1, Q2, Q3 and Q4. These are the all non-final state. And what is the final state? Set of the final state. Set of the final state, only two set, that is Q5 and Q6. The first step, we classify these all state into a two group, that is set of non-final and set of final state. And then we check how many state have a similar behavior with respect to the transition function, and how many this set have a similar behavior with respect to the transition function. If n number of state have a similar behavior, then n number of state are minimized into a single state. That is the minimization. Okay, now we check that is the pi 1. Now check. First we check Q1, Q0 and Q1. Is it the similar behavior? If it is similar behavior, then lie into the same group. Now Q0, Q1 and Q2, again check. If it is similar behavior, then lie into the same group. If have a different behavior, then lie into the different group. Now check Q0 and Q1. Now this is the 1 and this is the set 2. Now Q1, Q2 from Q0, Q1, or this is lie from set 1 and this is lie from set again 1. And from this transition, it is again lie from set 1 and set 1. It means these two have a similar behavior. We next test Q2. Now Q2, it is set 1, now it is set 2. It means Q2 have a not similar behavior with Q1 and Q0. Now again we check Q3. Now here is a set 2, here is a set 1 and here is a set 2. It means Q3 have a not similar behavior with Q1 and Q0, but Q3 have a similar behavior with Q2, because here is a 1, here is a 1, here is a 2, here is a 2. It means these two states have a similar behavior. Again we check the Q4. Now here is a set 1 and here is a set 2. It means Q4 have also a similar behavior with Q2, Q3 and Q4. So what is the next state? It means Q0, Q1 have a similar behavior. Q2, Q3 and Q4 have a similar behavior. Now Q5 and Q6 check. This is the set 2. Now this is the set 2. Again this is the set 2. This is the set 2. It means Q5 and Q6 have also have the similar behavior. It means lie into a same group. This process is continued until last two iterations are same. If last two iterations are same, then we compute the result. Now again check. Now this is the set 1, this is the set 2, now this is the set 3. Again checking. Now check Q0, Q1. Now it is Q0, now Q1, that is set 1. And now here is a Q2, that is set 2, Q1 that is set 2, Q3 that is again set 2. It means Q0, Q1 have a not similar behavior. It lies into the different set. Now, that is the second iteration. It means Q0 not have a similar behavior with Q1. Now, check this one. Q2, Q3, Q4. Now, Q2, Q4, it may it is lie into the second set. It is lie into a second set, and this is lie into a second set. Q3 and Q4 lie into the second set. From the A transition, we check the from B transition. It is lie into the third set. It is lie into the third set. Again, it is lie into the third set. It means Q2, Q3, Q4 again have a similar behavior with respect to the transition function. It means it is like Q2, Q3 and Q4 have a similar behavior. So that it is in a same group. Now, again check this state. Q5 and Q6. Now, it is set 3. Now, it is set 3. Again, it is set 3. And again, it is set 3. It means Q5 and Q6 again follow the similar behavior. So, it is lie into the same set. Then again, we partition this. Now, this is set 1. This is set 2, this is set 3, this is set 4. Again testing. Now, no need to check because it is single set, single state. So, single set, furthermore not minimize. Now, we check only this one and now we check only this one. If this next state, that is known as the pi 3, if pi 2 and pi 3 are same, then pi 3 is your final answer. Okay. Now, these three states, if it is here, then these three states are minimized into a single state. Now, check it. Now, check again. Now, check. Now, check this one. Q2, Q3 and Q4. Only we checking these three steps. Now, Q3 and Q4. So, what is where Q4 is lie? Again set number 3. Again set number 3. And Q3 again set number 3. It means these three states again in a similar behavior. Now, this one checking for the B transition. It is lie set number 4, it is lie set number 4, it is lie set number 4. It means again Q2, Q3 and Q5 have a similar behavior. Now, Q0, Q1, Q2, Q3, Q4 and now Q5 and Q6. These two states are similar. Now, this is your final answer. It means in starting how many states in DFA? 1, 2, 3, 4, 5, 6, 7. After minimize, these 7 states are minimized into 1, 2, 3, 4. 7 states are minimized into a 4 state. That concept is known as the minimization of the DFA. Now, we also design the machine of this state. Now, how we can design? That is very simple designing of this DFA. Here we are going to design the minimized DFA using this answer. Now, how many state? That is very simple. Now, Q0, one state, Q1 is another state, and next state is Q2, Q3 and Q4. This one is a one state, and another state is Q5 and Q6. And with the help of this transition table, we design the minimized DFA. Now, from Q0A, that is Q1. Now, from this transition, that is A, Q0B, that is Q2, here is a B. Q1A, now this is the Q1, from Q1A, that is Q2, from Q1B, that is Q3, so now A and B, Q1A, Q2 and Q3. Now, we move Q2, Q2A, Q4. Q2A, Q4, it means here is a self loop of A. Q2B, Q6. So, Q6 here, now that is the B. Now, Q3, Q3A, Q4, self loop. Q3B, Q5, Q3B, Q5 here. Now, Q4, Q4A, Q3, Q4A, same self loop. Q4B, Q6, Q4B, V6, and this state have minimized into this number of the transition. Now, Q5 and Q6, Q5A, Q5. Now, A for the Q5A, that is self loop, and B self loop. Now, this is the original machine, or this one is the minimized machine using this concept. Now, we move on the another example by which we can understand better understanding of the minimize of the DFA. Now, this one is the problem. And what is the problem? Q3 and Q4 is final state. Now, this one and this one is a final state. Now, this one is initial state. We follow the same process. First one, all state are minimized into the two part, set of final state and set of non-final state. Now, what is the non-final? That is Q0, Q1, Q2, Q5, Q6, Q7, and set of final state, that is Q3 and Q4. Now, this is the set 1. Now, this is the known as set 2, and again checking the similar behavior of the state with respect to the transition function. Now, first we check Q0, Q1. Now, Q0, Q1, that is Q1 and Q4. Now, Q1 and Q4. So, Q1 is that is set 1 and Q4 that is set 2. Now, Q2 and Q3. Now, Q2 is here set 1 and Q3 is set 2. Now, 1, 2 and here is also 1, 2. It means Q0, Q1 have a similar behavior. Now, we check Q2. Now, Q2, Q4. Now, here is a set 2 and here is a Q3 set 2. Sorry, Q0, Q1 have a not similar behavior, because here is 1, here is a 2, here is a 1, here is a 2. But Q1 and Q2, Q1, Q2 have a similar behavior. Q1, Q2 have a similar behavior because here is a 2, 2, 2, 2. Now, again check Q5, Q3, here is a 2, Q6, here is a 1. Q5, Q6, Q6 in 1 and Q6 here again 1. Q7 that is 2 and Q6 1. Now check which one is a similar behavior. Q0 Q1 set number 1 or Q2 again set number 1. So how many state? That is 1 1. Yani this state have a similar behavior. This state have a similar behavior, and this state have a similar behavior. Now check Q3 and Q4. Now Q5 Q7 Q5 Q that is 1, that is 1. Q6 that is 1, that is 1. It means Q3 and Q4 also have a similar behavior. Now what is the next state? Which one is similar behavior? Q0. Now 1 and 1 1. No, sorry. 1 and 1. Q6 only. These Q6. These two states are a similar behavior. Now Q1 Q2. Q1 and Q2 have a similar behavior. And remaining two state, which one state is remaining? Q1 Q2 Q0 Q6. Now Q5 Q6. Q5, how many states are remaining? Q7 2 1 2 1. Q5 and Q7. Q5 and Q7 have a similar behavior, and Q3 and Q4 have a similar behavior. We move on the next state, that is pi 2, that is set 1, set 2, set 3 and set 4. The same process applies, checking. Now Q0 Q6 again check. Q0 and Q6. Here is a Q1. Q1 is lie into set number 2 and Q6 is lie into set number 1. It means Q0, Q1 again not have a similar behavior. Now on, don't need to check if this one is different, then this one is different, maybe different. Q2, now Q2 in set number 2 and Q6 in set number 1. No. 2 2 1 1. It means these two states have not a similar behavior. So it means Q0 have a not similar behavior with Q6. Now we check Q1 Q2. Now this is the 4 Q4 that is set number 4, set number Q3. Now set number 4, it means these two states Q1 and Q2 have a similar behavior. Q5 Q7 check. Q3 again set number 4 and set number 4. Q6 I think in set number 1 and set number 1. It means Q5 and Q7 have a similar behavior. Now again check Q3 and Q4, 5 and 7. 5 and 7 lie into the set number 3, here set number 3, and here is the same behavior. We compute the phi 3 same Q0, we check, then find the same result Q1, Q2, Q5, Q7 and Q3 and Q4. Okay. Now in starting there is a total 8 number of the state. After they minimize, state 1, 2, 3, 4 and 5. 8 states are minimized into the 5 state. Now, this concept is known as the minimization of the finite automata. Next, another method minimization of the finite automata, that is known as the tabular method. We discuss into the next lecture.